Okay, so we want to now move on to exploitability management programs. And so this again is moving away from that traditional vulnerability management to exploitability management. So as I said before, exploitability is not limited to exploiting software, right? And that's a really important thing to take away from this webinar, because it limits your focus as to what you need to look at from a risk perspective within your vulnerability management program. So exploitability is any attack that results in a security breach. So as I showed you just before, one of the threat scenarios that we see for organizations getting breached is critical, exploitable remote command execution vulnerabilities. The other one is leaked passwords that can actually be used to log into your systems. The second one is not an exploitable piece of software. It's an attack type that can be used to breach your organization or your systems. So exploitability is any attack that can result in a security breach. So as I mentioned before, there's a number of exploitability factors that come into play when to actually have an exploit work, right? And this includes, as you see in that diagram, there's a whole bunch of security that you should have in place. Hopefully you've got a lot of this in place. If you don't, then there's less exploitability factors that are in place to stop it from working. So the more security you've got, obviously, the harder it is for exploits to work, and reduces your exploitability factors or the exploitability success rate. So some of these factors include things like network filtering. So if you have network segmentation within your organization, then if I cannot connect to an exploitable vulnerability as an attacker, then I can't break into that system, and therefore it's not exploitable, right? So there's a huge difference between having an exploitable vulnerability but actually being exploitable, right? So that network filtering actually prevents the exploit from working because I can't connect to it. There's also things within network filtering such as firewall holes. So if your firewall isn't locked down and it allows unnecessary access, and this includes externally from external attackers to your internet-facing systems. Quite commonly we'll see firewall holes, and what they do is, even though in themselves they're not a huge risk, because typically they allow the attacker to connect to nothing in a lot of cases. What they do though, from an exploitability perspective, is actually increase the exploitation success rate, because it allows an attacker to determine that a firewall hole exists. When they exploit the vulnerability, they can actually set up a backdoor on that firewall hole and then connect through to the backdoor. So that's what we call the highest exploitation success rate. If we can use what's called a bind payload, which sets up a backdoor listener and connect to it. If your network filtering in your firewall is all locked down, then what the attackers have to do is then start introducing guesswork into their exploitation. And that's, for example, exploiting a vulnerability but having the backdoor connect back to the attacker. And what that does is forces the attacker to guess an outbound port that's open that they can connect back to. And in some cases, that's going to be incorrect, and that's going to stop the exploit from working. There's also things like threat prevention. So if you've got things like next-gen firewalls or web application firewalls, for example, they're obviously designed to detect and prevent attacks, right? And that's great if you've got them set up properly. And let's say that we're sending an exploit over an unencrypted HTTP connection, and it picks that up and it drops it, and that reduces the exploitability of that vulnerability being exploited, even if your system is vulnerable on the other side. One of the things that we quite often see is that these next-gen firewalls don't have things like SSL decryption enabled in them. So the encryption, ironically, actually aids the attacker because they can send the exploit through the encrypted channel, which goes straight through the threat prevention because it can't see it because it's encrypted, and actually can exploit that system. So what you might find is that you cannot exploit a vulnerable system on, port 80 over HTTP, but if you send it over HTTPS, it goes straight through the threat prevention and actually exploits the system. So that's an exploitability factor. There's authentication. So if the vulnerability is in an authenticated component of the software, then you need to be able to authenticate to it. And that obviously, if the attacker doesn't have authentication to reach that vulnerability, then they're not going to be able to exploit it. Configuration hardening is another one. So if you've got your system locked down in a hardened configuration, that reduces the number of attack vectors that can be used or exploitation techniques that can be used to actually make the exploit work. So some of the examples I mentioned before are things like, locking down your Apache so that those insecure configurations are not present. So even if you're running a completely vulnerable version of Apache, it's not exploitable because you don't have the vulnerable configuration that's required to actually exploit it. This is when you think about organizations who have legacy systems on the internet. They've been sitting out there for a decade. They've got 10-year-old vulnerabilities, hundreds of these vulnerabilities on these systems, but yet they don't suffer a security breach, right? Why do they not suffer a security breach when they've got legacy systems with 10-year-old vulnerabilities in them? It's because they're vulnerable, but they're not exploitable, right? And that can be for any of these factors. And then you've got endpoint security. So if I've broken through all of those, I've gone through your network filtering, your threat prevention, your configuration hardening isn't stopping the exploit, then you've got things like your next level of defense, which is your endpoint security. And what that can do, depending upon your endpoint security, how it's configured, if it's up to date, if it's actually installed on the machine and enabled, whether that actually picks up the exploit attempt and stops it. So quite often you'll find that there are bypasses for some of the endpoint security. That's also very exploit focused. So there's different bypass techniques for different types of exploits. And some, are much more successful in bypassing endpoint security than others. And we've done tests across a large number of the leading endpoint security products, and not one of them has prevented us from breaking into a system when we put the effort in. So they may detect malicious activity, but if we tune the attack a bit, we can still break into the system. Okay, so phases of an exploitability management program. So some of these are similar to a vulnerability management program, but just with a different focus. Right, so one of the big challenges that we see across, especially enterprises, is a lack of asset discovery. So a lot of enterprises don't actually know what their assets are, or have multiple sources of asset CMDBs for their assets, and they don't know which one's actually true. So whether it's their Active Directory, or they might have, ServiceNow, or they rely on their vulnerability scanner, for example. They all have different views as to what your assets are. So the first phase is identify your assets. The next one is exploitability verification. So in your vulnerability management program, it's vulnerability identification. And you'll notice that it's looking for vulnerabilities and it's identifying them not verifying them, right? So that's why there's a lot of false positives. It's like, hey, this system I think has this vulnerability. I'm not going to verify that that is actually true. Whereas exploitability is all about verification, and this is how we automatically prioritize vulnerabilities that actually need to be fixed because they're exploitable. So exploitability verification is the next phase in our exploitability management program. So off the back of that, as I said, is prioritization. So the exploitability verification already out of, say, those 100,000 vulnerabilities that you have, automatically identifies the exploitable ones, and you may end up having, say, 20 exploitable vulnerabilities within your environment, for argument's sake. That's already prioritized, those 20 out of the 1,000 or 100,000. Even exploitable vulnerabilities are different. So not every vulnerability and not every exploit is the same. So even within the exploitable vulnerabilities, you've got different risk levels for those, and we'll talk about those in a second. So prioritizing which ones of those actually need to be remediated. Okay, we then move on to reporting and tracking. So being able to actually demonstrate to an IT team that your vulnerability is exploitable and on which systems is really important to actually convey that it's urgent to actually get it fixed. Also then tracking those exploitable vulnerabilities to make sure that they're getting remediated, and also you're getting the reporting that you need for executives and the board for strategic security activities. So once you actually convey, you provide the exploited vulnerabilities to the IT team or your application teams to get remediated, they obviously go and implement that fix. There are options for automated remediation, which we can chat about later. And then the next part of exploitability management is then retesting. So once the remediation gets put in place, that may be, for example, an upgrade to the software. It may be, a security patch is applied. It may be that it's a workaround or a configuration change that's been implemented. It could be that a password change has been done. Could be that network filtering is in place, or putting antivirus or any malware on your endpoint security onto the system, disabling services, whatever it is, right? But the next thing you need to do is then verify if it's no longer exploitable, right? And that's where the retesting comes in, to then verify the exploitability. Okay, so in some cases you'll find that it's still exploitable because, for example, the workaround that's been put in place wasn't effective or it wasn't implemented properly, and therefore you want to go back to that remediation step and then do the retesting, or else we rerun the exploitability test and verify that it's no longer exploitable. So that's really, really important for then feeding up to the executive or the board or the management to be able to say, okay, so yes, this month we had 100,000 vulnerabilities. Out of those, there were 20 that were actually exploitable this month, right? That's a much more useful metric for management, executives, and the board to actually look at and say, wow, we can actually be broken into right now. What are we doing? What have we done about it, right? If you've gone through that remediation and the retesting during that month, you can say, all right, we had 20 that were exploitable. We implemented remediation actions. We've run the exploitability test again, and now we don't have any exploitable vulnerabilities, right? And so that's a much more useful metric for a board to be able to say, right, there was a significant risk that we were going to suffer a security breach during the month. Our team have remediated that and confirmed that we're no longer at risk of that at this point in time. And So rather than looking at 100,000 vulnerabilities that we've all got to run around in circles trying to patch, you can actually say, right, well, this month we've actually mitigated the risk and we've got sufficient technologies and people in place to be able to do that without wasting their time on things that aren't actually exploitable. And so with that, that then frees up time so that we're only focusing on 20 exploitable vulnerabilities to then focus on strategic security initiatives within the security team, which might be fixing up the fundamental problem as to why they're exploitable in the first place, or other strategic initiatives, which might be, security architecture work, or, upgrading firewalls, or whatever it is, implementing more security automation. Just because at the end of that month, you've got no exploitable vulnerabilities, it does not mean that the next month you won't either. So more vulnerabilities are coming out and more exploits are coming out. So there may be that you weren't exploitable for some of those vulnerabilities because there were no exploits available. Or it could be that the exploits were not mature enough for it to actually work. So the exploit may have actually failed. Right? And that's completely valid. It may have also not been, the exploit may not have supported, in the previous month, supported your operating system version. Right? There's a whole bunch of different factors that come into exploits working. As that month goes on, there may be new versions, and this happens all the time, new versions of these exploits that get released that then support additional operating systems. They fix bugs that were happening on different operating systems that are now stable. So they start off relatively unstable and very targeted against specific OSs. They then get more mature, they get support more operating systems and become stable exploits. So what you might then find is that that exploit is matured, or new vulnerabilities that have come out, and the next month you've then got 10 exploitable systems, right? Again, you identify the 10 exploitable systems out of the 100,000 vulnerabilities, you remediate them, retest them, report up to the board. Right, this month we had 10 exploitable vulnerabilities. They've all been remediated and we've confirmed that we're no longer vulnerable. Again, gives clear insight into the risk for the organization, and you can then trend that actual risk of being breached rather than vulnerabilities. And that's where Gartner is saying you need to move towards exploitability.